Okay, class. Today we'll use ANSYS to work on a simple problem to show you, give you a rough idea how ANSYS works. Okay, so let's look at the problem first. So the problem is we will stretch a stainless steel bar with a cross area 20 millimeter by 20 millimeter, and the length of the stainless steel bar is 100 millimeter, and we want to calculate the elongation. So we first work on theory, see that theoretical result, and then we'll use it to compare with our simulation result. So let's first calculate the stress. The stress equals force divided by cross area, and then strain equals the elongation divided by the length, original length of the bar. The relation, we'll use the stress-strain relation, sigma equals E Young's modulus times strain, epsilon. We plug all the variables into the stress-strain relation, we'll get elongation. Theoretical value is 6.48 times 10 to minus 4 meter. And we'll use this value as benchmark. Okay, now we jump into our ANSYS. So first open the Workbench. At the Workbench, you'll see two areas. So you have a toolbox and we have project schematic. In the toolbox, open analysis systems. So in analysis systems, we have all kinds of different systems where ANSYS can work on. So we'll use static structure model. So we can drag it into the corner where it has a rectangle and move it there. If you move to other area, it will not work. Okay, so once you release it, you will see our project with the title static structure, and then you will see other cells from engineer data, geometry, and then all the way to the result. So we'll look at it one by one. So first we look at the second cell, it's the engineer data. That's where we define material properties. To assign all the properties from Young's modulus to the Poisson ratio. So double click on it and you will open engineer data. So here for stainless steel, we can find it in the engineer data source. So what do? You click on engineer data source and you will see that there are different materials, general material, additive manufacturing material, composite materials. So you will see that stainless steel is a very common used material. It's already there, so you can click the add button and it will show up in this region. So the stainless steel has been added. Structured steel is a default material, but we'll not use it. We'll use stainless steel. Okay, now we can come back to the project. We close it, come back to the project. We go to the third cell, which is geometry. That's where you add the geometry. So you can double click on it, which will launch a geometry editor. There are two geometry editors. One is space claim, and that's what we will use for today. So take a few seconds to launch it. Let's wait. Okay, now we come to space claim. In space claim, this is our working area. It's a 3D XYZ 3D space. So what we'll do is we'll first create a cross area. So cross area is a square, 20 millimeter by 20 millimeter. To create the cross area, we first use a 2D view. It's a plan view. So you go to Design, Plan View button. You can click on it. You get the 2D view, and there you can sketch the square. So to sketch the square, go to the sketch mode, click on it, and then you can use different shapes. So today we'll use rectangle, and then to do that, you click on any point and then stretch it around and go all the way to 20 millimeters, and that's the cross area. And then once we have cross area, we protrude the cross area up, that will get the steel bar. To do that, we need to use a 3D. So now we come back to 3D view, and then we use the pull function. Pull function is a very useful function for space claim, which you can use to generate 3D shape. Click on it, and then click on the surface, and then we pull it up, then we get 3D material. Okay, so here we can change the length to 100 millimeter, which is the length of the stainless steel bar, and then we get it. And then on the right corner, and you have different functions. You can move it. It's a pan function, you can move it. Pan function, you can move it around. You have a spin function, then you can rotate it around. Okay, anyway, we'll learn this function later, but for today, that's what we have. And then once we have this geometry, we use Control S to save it. So let's save it and name it as design 4. This is geometry we'll use. Save, and then we can close space claim. We'll finish the geometry design, and then come back to Workbench. We'll go to the 4th cell, which is a model. So double click on the model. Take a few seconds to launch another app, which is the modeler, where we can do the structural analysis. All right, it's opened. This is ANSYS mechanical modeler. So still take a few seconds to load the geometry. So right now, if you click on any button, it doesn't work because it's still working. Let's wait. In this outline region, the geometry will be loaded. All right, now we have this geometry. So the first thing is you click on the geometry, click on this add button, and click on the solid. So select the solid, choose the material we'll use. In the details of the solid, the material we'll use is, go to the material. The material we'll use is stainless steel. So we'll use stainless steel instead of default structural steel. So we'll use stainless steel. Then we get it. And the next one is go to the mesh. So right click on the mesh, and then you will see that drop down menu, generate mesh. So by the generate mesh, will cut the object into small pieces, and then we can do finite element calculation. So now we have the mesh. The next step is apply boundary condition. To apply boundary condition, right click static structural, and drop down menu, apply. Go to insert, and go to fixed support. So to apply boundary condition, recall that we'll apply fix one end and apply force on the other end. So let's first click on the fixed support, and once you have fixed support, you'll see the details of fixed support. We need to apply this boundary condition to some object. So we first need to select where we want to apply this fixed support. So we want to apply fixed support on one end. So this surface is where we want to apply force. We'll apply to the other end. So we will use rotate to move it around. And this is the surface we want to apply the fixed surface. And then apply, then we get it. The next one is apply another boundary. Right click, and we get a drop down menu, insert, go to the force. So, and then we have details of force. We need to apply this force to another area. So we move back to the other area, and we select, see the surface. So see, you click on this, that means what you select is a face. So by default is a face, and if you can apply to edge or vertex, but now we will apply it to the surface. And then we select the surface, then click apply. And then we need to define the value of the surface. So to define the value, we'll use component instead of using vector. So we use the component, then we can apply force along XYZ direction. Here we'll apply to, let's see, this is y direction, we'll apply to y direction, and the force is 10 to 5 Newton, and xyz is 0, xz is 0. So click, and then we finish. The boundary condition has been applied. The last step is to solve it. Before to solve the problem, we want to insert the output. The output we want to show is the elongation. We want to show the deformation. We'll use total deformation. And then after add the total deformation, we can solve. So right click solution, drop down menu, click. It takes a few seconds to do the calculation because this is a simple problem without not many pieces of element. Now we get the result, and then you can click total deformation. You will see the deformation, and this is skill bar, and you will see that there's an animation that if you apply the force from small to maximum, and you can see that how it deforms. Well, we can also get the value. The maximum value is 6.4 times 10 to minus 4 meter. So look at the units of meter. If we compare with our result, is very close, 6.4. And then we come back. The reason that is not exactly the same, because one is because of numerical calculation, the other one is because of the fixed support boundary, which is not exactly as we applied. Because if fixed support means that you are not allowed to move along y and x direction. So we'll solve this the small issue later. But right now you have a basic idea that how to apply ANSYS to solve a simple problem. And that's what we have today. We'll talk to you next time.